Hi, everyone. Welcome to another installment of Ed Talks, the podcast where we explore the energy storage industry and the factors that are driving the different design, manufacturing, and deployment strategies for OEMs, manufacturers, and operators. Today, our focus is on enclosure design, which is really where our company, CMP, has developed a great deal of experience over the course of the last 5 or 6 years supporting this market. When we launch a design program or intensive DFMA exercise with OEMs in this space, it really all starts with the enclosure. Most companies are intensely focused on those aspects of their offering that serve to set them apart from competitors. And so things like energy density, inherent safety, system duration, and of course sales and marketing strategy are first and foremost in their minds. The enclosure is kind of a necessary evil. Early in our ESS journey, we worked with a lot of converted ISO containers, which remain for many companies a part of their solution. Images of port facilities overflowing with empty containers available at or near scrap value drove a desire to upcycle them into ESS products. I get it. The batteries arrived in containers from overseas, so might as well put them to good use, right? Unfortunately, it's not that easy. Standard containers are really anything but. There are a half dozen companies in Asia that are building slightly different versions of these containers. And so if you want to double down on the twin killers of stable manufacturing processes, dependency and variability, these ISO containers are your friend. Once they've been sufficiently modified for the purpose of storing energy, like adding doors and panels, floors, insulation, the list goes on, you end up with a manufactured product that is essentially a bespoke enclosure. And from a TCO perspective, a solution that has failed to meet expectations on both cost and availability. When OEMs are looking for partners and designs, they're considering a lot of variables. And chief amongst them are ability to scale and industry experience. That's why the leaders in this industry, the Teslas and Fluences and Wartzillas, have all decided to commercialize on custom enclosures. Custom enclosures, unsurprisingly, come in all shapes and sizes. Some are designed to work as a large standalone system, offering high levels of redundancy and the ability to support smaller C&I as well as islanding applications. Others are modular, where each unit retains minimum functionality and they're strung together to provide the desired storage capacity. These modular solutions also offer a great deal of flexibility when it comes to system augmentation, as low-cost modules can be added to an existing string as battery capacity devolves over time. The decision to choose a large monolithic system or a smaller modular design is a difficult one to make. Logistically, it can be easier to transport and install smaller systems. However, site installation costs for a given amount of storage may increase as a consequence. For this reason, though consideration of installation cost is always important, we see modular systems using more creative strategies to reduce deployment time. Ultimately, these systems have much more in common than not. They need to keep the weather out. They need to survive California deserts and Alaskan tundra and the Florida coastline. They need to be serviceable for 20 plus years without dissolving into a rusty mess. All OEMs using lithium batteries need to consider things like active venting solutions, deflagration panels, and dry pipe assemblies as part of their safety strategy. Flow and liquid cell systems can sometimes emit small quantities of aerosolized electrolyte or potentially hazardous gases, creating internal environments that require greater levels of corrosion resistance. DC buses and disconnects need to be safely accessible. Maintenance is going to be a part of any deployment, and ensuring that technicians can keep these systems running by accessing filters, changing BMS modules, swapping batteries, and inspecting fire suppression components and busbar connections. All of those need to be considered. And finally, cost. Modular or monolithic, lithium or flow, any enclosure designed for the industry needs to be cost effective. Companies like Tesla have shown us what an optimized and automated approach can provide, but hitting the required volumes is a major challenge for most entrants to the market. Modularity, designing for automation, and leveraging creative assembly strategies can all contribute to the cost effectiveness of a design. In summary, ESS enclosure design is complicated. Performance, manufacturability, and cost all need to exist in some kind of Zen-like balance. So include all your stakeholders, from manufacturing to procurement, even your clients in the process. Remember always that 80% of the cost of a solution is baked in at design. So while time to market is important and paralysis through analysis is real, skipping important steps during design can cause you and your clients existential pain down the line. Thanks a lot, everybody. I hope you enjoyed it today, and we look forward to seeing you again. Bye-bye.